Welcome to lesson 2 of this Arduino C++ course, and as it says on the screen, today we're going to be looking at some C++ syntax and continuing with using the serial monitor. Now, as with all the other lessons that will be part of this course, if you click on the link below the video, it will take you to the lessons page on the Digital Town website. And today, lesson 2 is the C++ syntax and serial monitor, and there is the download for the code for this lesson if you want to look at the code separately. So at the end of lesson 1, we'd learned some basics about our sketch. We'd started to look at how the setup varies from the loop, and also a little bit at commenting code, and then finally, to test the Arduino, we had done a serial print once in the setup that appeared just the once, and then of course the hello world that we put in the loop, and as you can see it is churning away merrily. And if we go to the webcam, you can see that on the web camera you'll notice that these lights are permanently on. These lights, there is one here, the RX light, and this is information that, if you like, is being transmitted out all of the time from the Uno, and because it's sending this data so quickly, you don't actually see the lights flash anymore. It just looks like it's permanently on. Now today, as the title of the video said, we're going to start by looking at syntax. Now, if we think of the Arduino IDE as a word processor, the syntax is, if you like, the punctuation. Now, the difference between a word processor and the Arduino IDE is if I'm using a word processor and I get my punctuation wrong, the word processor will still work. It will still print out my letter, even though it's badly formatted. However, when it comes to programming, C++ is very, very fussy. If you make a mistake in your punctuation, in your syntax, you will get an error and your code will not upload. So let's have a look at some of the most basic syntax and the bits that, if you like, most people will get wrong. And some of us who've been programming for a long time still get wrong. So don't panic if you make these mistakes. So the first bit of syntax we're going to look at today might seem quite a simple one. It is the semicolon, and the semicolon marks the end of a line of code. So it might sound strange if I take this line here and paste it in there. The compiler will be quite happy with that. If I upload that code, it will say I have compiled the first line, and then I have compiled the second line. So unlike us, where we would sort of be thinking, hang on, that's one line of code, to the compiler that is two. Now, don't write your code like that. It's always best to, if you like, put it on separate lines, because it's just easier as humans to read it that way. But it's very important that this semicolon is on the end of the line. If you delete that semicolon, and I now try to compile the code, you will see that I get an error. And if I just bring this up so you can see a little bit more of the error, what it is saying here is on line 15, character 1, that's what that is about. So line 15, character 1, it was expecting an end of line, a semicolon, before it came to this curly bracket. And that's because that semicolon is missing there. So that is our first bit of syntax, and you will miss those off quite a bit. So if you get this error, now you know what the problem is. Now, moving this down so we can see a little bit more clearly, let's have a look at the next issues. I'm just going to compile this again just to get rid of the error. The next thing that you need to understand with the syntax is when it comes to brackets. So you can see here we have the setup function. In a similar way, this serial begin is a function, and again, serial print line is a function. But one of the things I want you to notice is there is an open and a closed bracket. The same, there is an open and a closed bracket, and once again, there is an open and a closed bracket. And with all of these functions, you will find this open and closed bracket, and it is essential that you do have an open and a closed bracket. If you miss one of these off, let's just take one out, compile the sketch, and we get an error. And that error this time, it was expecting the closed bracket. So I will just put that one back, recompile the sketch to fix my problem. Now that is a normal, if you like, smooth bracket. There is also what they call a curly bracket, or a curly brace, some people call it. These brackets are a lot more difficult to keep track of, and it is why there is this line that goes up here. That goes from, if you like, the start of this particular function to the end, and it is saying that this curly bracket is connected to this one up here. But it is a real problem at times. Sometimes there could be 50, 60 lines between this bracket and this bracket, and sometimes there are functions within functions. So it's one of those things, now and again you will miss those off and you will get an error, and once again we will just compile the code to look for the error, and once again it says it was expecting the curly bracket before it got to this loop. So let's put that one back in. And let's just compile again. There we go, everything's working. So now that we've got the very basics of our syntax sorted out, and at least if we make the errors, we now know what the errors are, let's take a look at the sketch that we've got running again. So if you remember, we were sending out to the serial monitor, just printing out sketch 1, and then we had hello world running continuously. Now that's not particularly helpful for us, so I'm going to comment that out, and the way I'm going to comment it out is just highlight the line and then go up to edit and comment, and as you can see it now comments the line out for me. You can comment out multiple lines by doing exactly the same. And once again, if you want to uncomment them, just re-click the same link. So let's just upload that code so that we get rid of the endless output in the serial monitor. There we go, it's now stopped, and I'm going to clear out the content. Next, I'm going to start to look at how the serial monitor works, and do a little bit more in depth than we did yesterday. So we have this function that starts off serial begin, and it has a speed here of 9600. Now the most important thing about this speed is that it is the same speed as you have in your serial monitor, because as we saw in lesson 1, if those are different, then there will be a problem and you will get a really strange output. But this code, what does it actually mean, the 9600? To find out, I've brought up the reference again, and if we go down to serial, scrolling down, we have serial begin, and the value that is put in there is the speed that we want the serial monitor to run at. Now this speed is in bits per second. Now if you're new to programming, things like bits per second can get a little bit frightening. Bits per second, if we look at this word here, we've got sketch 1. So we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 letters there. Now the speed bits per second is not letters or characters per second, it is bits per second. So I'm going to bring up my calculator, and I'm going to put it into programmer mode. And we're going to start putting in some values. So let's take the value 1. We can see that its binary value is 0001 here. I'm then going to add a 2, 1100, 3. Now, as you can see, suddenly it's gone to 8 bits, 8 zeros or ones. And when you are thinking about a character, every character that we see here, each individual character is 1 byte, and a byte is made up of 8 bits. And if I just bring up what is called an ASCII table, here we see our ASCII table, and if we go back to our sketch, the first letter that we're sending is a capital S. Looking on the ASCII table for a capital S, that has a decimal value of 83. So if I now go to my calculator, type in 83, it will then send 0, 1, 0, 1, 0, 0, 1, 1. So for each character that we send across, the serial monitor will send 8 bits that are either a 0 or a 1. Now that means that when we go back to our sketch, when we see that we have a baud rate of 9,600, that doesn't mean that we can send 9,600 characters per second. That actually means that it's 9,600 divided by 8 realistically. There are some slight overheads that make this a little bit odd, but realistically you're looking at around 1,200 characters per second that we can transmit. So I think that's more than enough characters for us to be reading at the moment. So I've added some extra characters from the ASCII table that I had. So we can now see that a capital S, we're going to send 83, K 107, E 101, T 116, C 99, H 104, and finally the value 1, the character value, is 49. Now, the reason that we know this is text values that are being sent, ASCII values, is we have these double quote marks. So that defines the item between the double quote marks as text. So now if I take this line, copy it down, if I put in 9,600 again, that is not sending the number 9,600. It is sending the ASCII value for 9, followed by the ASCII value for 6, then 0, then 0. Now, thankfully, we don't have to panic too much about how all of this works, because the serial monitor, providing the baud rate is set correctly here and here, will work all of those things out for us. However, there is something that it is worth noting. I'm going to put another line in here. And this time, I'm just going to put the number 9,600. I'm going to put the end of line on there. I'm going to compile the code and we will watch what comes out in the serial monitor. There we go. Sketch 1, 9,600 and 9,600. So the serial monitor recognizes that as the string 9,600. It's just treating that as text. Whereas here, it is sending the number as a string. Now, you might think, well, what is the difference? Well, the difference will become quite important in a moment. Let's do some mathematics. Serial print line 1 plus 1. Let's keep the maths easy. What does 1 and 1 equal? Let's upload it. One and 1 equals 1 plus 1. That's because we have those double quotes, therefore it sees 1 plus 1 as a text string rather than mathematics. Let's clear the output. I'm going to copy that again, paste it in, except this time I'm going to remove the quotation marks and we will upload it again. Now when we look at the output, we see that the output for 1 plus 1 is still the string 1 plus 1, whereas without the quotation marks, it actually outputs the result of the mathematics that we have done within the brackets. Now you may wonder why we are just outputting a string versus the mathematical formula, if you like, for 1 plus 1. Well, I hope now things will start to become clear as we start to use our first variable. So within this little formula, we have used the values 1 plus 1, but when you are programming, values are changing all the time. So a variable, think of it as a box to store your value in. Now, for anyone who's had to store anything, it's good to use the right size box. There's no point using too big a box, but obviously you can't use too small a box. So the variable we're going to start with, we're going to call it an int. That is short for integer, and we're just going to give it the name myInt. And that's it. That's created our variable. Now this variable, we can tell its type from this name here. If we go to the language reference, if you want to find this, if you scroll down the language reference to data types, there's all the different data types, and the one we are using here is an int, and it is able to store a value of minus 32,768 to 32,767. So you can store any value within that range within this box that we've created, our variable box. So going back to our code, when we create the variable, if we don't put any value after it, then its value defaults to 0. If I was to put equals 2, then when that variable is created, it automatically starts with the value 2. So we're going to use this variable and we're going to print its output to the serial monitor. So to do this, I'm going to do it a bit like I would debug some normal code. So we're going to put another line in, and this time, instead of going serial print line, I'm just going to put serial print. And we are going to put in here myInt, there we go, and I'm going to leave a little gap there. So at that point, that is not putting the value of myInt, that is putting the string myInt. Now, because I haven't got the ln, there will be no carriage return. I'm now going to put a second line in. This time, obviously, I'm going to take out the quotation marks and I'm going to put the ln in. Now remember, it starts with a default value of 0. So when we compile this bit of code, we see in our serial monitor my int, so that is this string here, followed by the value 0, which is the value of our variable my int. Now, the names that you choose for your variable, you can pick whatever name you want. It's very useful though if you create a name that, if you like, reflects what that item is storing. Now, I've just added an explanation of those lines, so if you want to download the code afterwards, you can just take a look at it. So the first line outputs the text my int, the second line outputs 0, which is the value of my int, and this becomes really useful in our code. So now we're going to do some mathematics. So we're going to go my int equals 2 plus 2. Then I'm going to copy these lines again and paste them below. So now I'm saying that the variable, my integer, instead of being 0, I want it to be equal to the value of 2 plus 2. Now I've uploaded the code, and as you can see, we have an output. So first of all, we see my int equals 0. Then we do our little bit of mathematics, and all of a sudden, my int, when we print it again, this time it has a value of 4. And this is why outputting information to the serial monitor is so useful. So we've now got our value my int. Let's change it again. This time we're going to go my int equals my int, so its current value, plus 34. Once again, we can put the outputs and upload it. And now, as you can see, we had the original value 0. 2 plus 2 now makes it to 4. We've then taken that value stored in my int, which was 4, and we've added 34 to it, and now its value is 38. And this is why the serial monitor is so useful. As you are designing your code, being able to write information to the serial monitor just allows you to keep track of what is going on and helps you to find any bugs in your code. Now, I'm going to end the lesson here today, but I'm just going to show you one other little item. You may notice that my screen has changed color. If you go up to File and Preferences, you can change the theme between dark and light. Now, I prefer the dark setup, just because if you're programming, especially if you're programming for long periods of time, having the black background is actually easier on your eyes. So don't panic that I'm using different software. I've just changed the view because it's better for my eyes. So that's the end of today's lesson. Feel free to download the code, have a mess around with it, change your variables, maybe add your own variable in. Just have a play, take out some different characters and see if you get any bugs, but just experiment with the code that we have looked at today, and I will see you in the next video. So bye for now.